look at this here, okay? All right. We are talking about determining intervals in which a function is increasing or decreasing. We get to not only, so we're gonna, this is like my absolute favorite stuff. Hello, Denise. To do problems about and to teach. It's like, I would rather do this lesson than almost any other lessons because it's fun. Okay. So let's just start with, what does it mean to be increasing or decreasing? So if you are in the alphabet A through G for your first name, tell me what it means to be increasing. A through G is increasing and H through Z is decreasing. So tell me what increasing and decreasing means. Can you tell me that in the chat, please? I think we may have done this the other day, but let's just review. Okay, Erica says up. It's that simple, right? Decreasing, going down, becoming smaller, going up, going down. That's exactly what it is. It's either going up or it's going down. Okay, so the next part of my question is on this graph that we have here, because this is the graph of an original function, and it's super important that you make sure you identify what you have a picture of when you have it, okay? Can everybody tell me, not just Alpha, so tell me in the chat what intervals or intervals is it increasing on? Can you tell me in the chat, where is it increasing? All right, apparently we need to review this. Okay. Oh, we've got some people. Okay, good job. Jesus, excellent work. Okay, so let me review a little bit. And if I'm gonna do the increasing, and then we're all gonna be superstars at decreasing. Okay. So just reading this from the graph, we did this in the trig class. I don't know if you guys did it in pre-calc, okay? But I know we did it in the trig class. I'm pretty sure. Increasing, it would be here and here, everywhere where it's going up, okay? Remember the way we write interval is that I usually write it in interval notation. We would write it as closed, though. Remember the brackets? So 2 to 5, and from 7, and then notice the arrow on the end. Arrow on the end means it goes to infinity. That's why I said Jesus did a great job, because he got the infinity piece. The other way I could write this, I could use inequality notation like Erica did, is 2 less than or equal to x less than or equal to 5. And I could also say that that's x greater than or equal to 7 would be another way to say that. Okay. So now that we kind of have refreshed our brain on what increasing is and how to write it, can you guys do decreasing in the chat for me? So what is it? What would my decreasing intervals be in there? Put it in the chat. See if you can use the right notation. Probably interval is going to be easier to type. What are we thinking? All right, Erica's got an option in there for us. Nice. Michaeli, nice. And Jaden, great. Pearl, awesome. I'm going to give it another minute here to make sure everybody's getting an opportunity. Make sure we're using our X values, not Y values when we do this. Okay. Unless it specifically says value, the word value, we always use X. Okay. All right. So I'm just going to double check for those of us that are still off track just a bit. Most of us look like we're there though. So we're going from -3 with a bracket to 2 with a bracket. And then we're going to go from 5 with a bracket. And it looks like that X value right there is 7 with a bracket. Or we could write it -3 less than or equal to X less than or equal to 2. and 5 less than or equal to x less than or equal to 7. Okay, so let's read through the fine print, okay, and then we'll fill in the stuff that's on the left there. There is often confusion about why we include endpoints when discussing increasing and decreasing intervals. The confusion is really due to a misunderstanding of what we mean by discussing intervals of increasing or decreasing behavior. It is important to understand that we are not ever claiming or discussing a single point. So it's not a single point on the graph is as increasing or decreasing. How could one point be increasing or decreasing? It's just a point. So you have to always have an interval of stuff for it to be increasing or decreasing. Infinity is always a parentheses because it's open. We're going to cover that again here in just a second, okay, Marilyn? But it's always a parentheses because it goes on forever. It's considered open, not closed. All right, rather we define increasing as follows. So for a function, f is increasing on the interval whenever f of b is greater than f of a. This is kind of like saying y sub 2 is greater than y sub 1 when x sub 2 is greater than x sub 1. What it means is if this is your x sub 1, y sub 1, there's x sub 2, y sub 2. It keeps getting bigger and bigger and bigger and bigger. That's what increasing means. Okay, decreasing is the other direction. More simply, we must include all x values where the current point is higher than the point right before it. This means that even points where the graph seems to stop increasing, we must include those x values in our interval, since that point is still higher than the point right before it. So basically we're saying we want to keep it closed, okay? We can define decreasing intervals in a similar way, which is why we use closed intervals whenever a function is defined for both increasing and decreasing intervals. So when we include the endpoints in our intervals, don't be confused and think that we are claiming that the function is increasing at that point. We are only starting at that point and is still higher than the point on the right before or after it, okay? All right, let's look at the left-hand side. If you've been one of the people who's been going to the Saturday reviews of Mr. Lundstrom through AP Readiness, I stole a lot of this from him, okay? So hopefully this should look somewhat familiar to you. So a function is increasing if f prime is positive. So when they give us, they're never going to give us a picture of an original function. They might give us the picture of the derivative, and we have to decide if the original is increasing or decreasing. They might give us the original function, not let us use a calculator, and we wouldn't have to be able to figure out increasing or decreasing. It's something crazy that we haven't seen before, right? That we can take a derivative of and figure out increasing or decreasing from the derivative. F prime equals negative, a negative number if it is decreasing. All right, so we did this on, I think it was Wednesday, right? Yesterday? Did we do critical numbers yesterday? To find intervals of increasing or decreasing, do a sign chart. We touched a little bit. There were a little bit of sign charts in the end in some of the problems on the last unit in the, what was that thing called? In the progress check, okay? But we're going to actually officially do them today. So we're going to find critical numbers. That's our first step. So you've already know step 1. That's what we did yesterday, okay? Set up the interval from negative infinity to infinity in a table, stopping at each critical number. We're then going to pick x values. You get to pick your own x values in the interval. We're going to plug those into, oh, I totally have the wrong thing written there. Plug those into the, to f prime. Just realized that this is totally wrong over here. I gave them the wrong thing. I have to fix it. If positive, then write increasing. If negative, then write decreasing. Write the intervals in interval form. So typically with the brackets, you can use inequality, it's not wrong, but I typically go to the interval form. And you always have to justify your answer whether or not it says to. You always write a sentence after to explain what the thinking, okay? So because f prime, and you need to really word it right out the word because I am being very lazy right there, is greater than 0, which means that it's positive, or f prime of x is less than 0, which means negative. All right, a couple more little definitions, and then we're going to get into a couple problems. And we're only going to do 2 examples. We're going to do example 1 and 2, and then call it good for the day because I have that other lesson for you guys to watch. So monotonic means that we are always increasing or always decreasing. Always increasing or always decreasing. So meaning that it's either always going up or it's always coming down. That's something that's monotonic. It goes one direction. Mono is one. Okay? So when we do, and this kind of goes back to Marilyn's question, okay? If when we're increasing or decreasing, we always use brackets, okay? Unless you have infinity, when you have infinity, you use parentheses. I don't know why I drew for an infinity. We always use parentheses. Okay, we ready for this? This isn't that hard, and it's super exciting, and it's like my favorite, okay? So I hope it'll be your favorite too. I know that last year, the BC kids, I promise, it's easy, okay? And once you get into it, it's like, this is the best thing, the best way I've ever seen to do this. So we're going to do something called a sign chart here in a minute. There are lots of different ways to do these. When I saw it done this way, I will never go back to any of those other ways, okay? So it makes so much sense, okay? So, and it helps us with a lot of different things, and especially when we have to do like layers of this later. You want your helmet off? Okay, I can do that. There you go. Okay, go play. All right. So on what intervals is the function f of x equals x squared plus 8x plus 10 increasing and decreasing? So we need to figure out both increasing and decreasing. Sometimes it will only ask us one or the other. I threw both of them in there, so we got practice with both, okay? So the very first step, remember I'm going back to my step here, is we got to find the critical numbers. Tell me in the chat, how do we find critical numbers? How do we find critical numbers? All right. Erica's saying we take the derivative, set it equal to 0. Perfect. So let's do that. F prime of x equals 2x plus 8. I'm going to set it equal to 0. Good. I got Brody and Marilyn and Jaden also telling me the same thing. Awesome job, guys. We're going to let that equal -8. And then x equals -4. So that's my critical number is -4. So either I have, eventually we're going to be able to tell if it's a max or a min. We're not ready for that part yet. Okay, so that's going to be either a max or min, but we're going to look and see if it's increasing or decreasing. So here comes my sign chart. Okay. These are, no, it's not an X, it's going to be intervals. I'm going to write my intervals on the top of this chart. If they don't give me like a specific interval, I know I'm always starting at -infinity. And I'm going to stop that first interval at -4. So what you got to think of this is like a yard. All right. So this yard includes everything that's from -infinity to -4. And I'm going to draw a fence between the yards. That was a terrible fence. I would get fired for drawing that a fence that's for building a fence that sloppy, right? That's a much better fence. It's still not perfect, but it's better. On the other side of the fence, I'm starting with -4 and I'm going all the way to +infinity. And these are representing x values. Our intervals, again, are always x's. Okay, so now I'm going to pick x. I'm going to learn about f of x, and I'm going to talk about my original function. Okay, so now I get to pick some of my own numbers. So I get to pick the numbers that go in this row right here. So I have some very favorite numbers to pick that I do every single time. So one of them is 0, because 0 is super easy to plug into things, right? Other ones that are easy to plug in are plus or minus 1. Can anybody guess my other favorite? That's like the first top 3 for me. What do you think my 4th and 5th favorite are? What do you think? Give me a guess in the chat. What do you guys think? my other favorites be? I want something that's super easy to calculate with. That I can calculate fast in my head. Fast in my head. All right, 2, 3. Any other guesses? Because it's not 2 or 3. What do you guys think? Oh, Brody, was your brother there? And Fallon? Okay. So it is in fact 10. Plus or minus 10. That would be my third. That would be kind of my fourth and fifth pick. Is that if I can't use 0, I can't use 1. I'm going to pick 10. Okay, because it's easy to calculate. Okay. All right. So in between negative. So I am picking this number. Okay, and it could be these numbers. It could be 2 or 4 or 3, whatever number you want. It doesn't matter. But these are the numbers that I typically try to choose from. So I know between negative infinity and negative 4, I can't use 0, I can't use 1 or negative 1, so I'm going to use negative 10. Okay? And then between negative 4 and infinity, I'm going to choose 0 because that's the best number ever to plug things in, to plug into things. Okay? If 0 is there, I'm going to pick it. All right, so I'm going to find my most simplified form of my derivative, which is that guy right there. And I'm going to plug these numbers into that. I do not care what the answer is. I only care about the sign of the answer. All right, so the sign of the answer. So we're going to plug this guy in to right here. I'm going to do this in my head. So negative 2 times negative 10 is negative 20. Negative 20 plus 8 is going to be a negative number. I don't care what negative number it is. I just know that it's negative because negative 20 is going to win over positive 8, right? All right, I'm now going to plug in my 0 into here. So when I plug my 0 into there, I'm going to see if you guys understand what's going on. When I plug 0 into there, do I get a positive answer or a negative answer? Can you tell me in the chat? All right, nice job. We are getting a positive. Okay, so what that means is we just figured out that my derivative is negative between negative infinity and negative 4 and positive between negative 4 and infinity. And without looking at the graph, okay, I know that my original function, because the derivative is negative, it is decreasing, okay, on that interval, and it is increasing on this interval. Okay, so it's decreasing and then increasing. All right, but we can't leave that. We cannot, the AP exam will not accept a chart as an answer. So we have to write a concluding sentence, and we always, that's part, and our justification is part of that. So we're going to say that F is increasing, okay, and you tell me your interval on. It's kind of like a sentence frame. We're going to write the same sentence all of the time. I happen to pick on increasing first. It doesn't matter which one you do first. Increasing on negative 4 to infinity, you really should write out the word because. I'm being very lazy. F prime of x is greater than 0. Or you could write that f prime of x is positive. Both are acceptable, okay? I don't know if I did the drag and drop or drop down things. I might do that on the next test to have you guys fill in, okay? But I might have like all the possibilities there, so you have to get the right words in the right place. It might be a very bare skeleton of a sentence, okay? On this, and then I usually conclude it with on this interval. Okay, we're going to do the decreasing sentence too because I asked for both. So F is decreasing on, and then I write the interval. I'm reading that right out of the sign chart. So from negative infinity to negative 4. Because, and again, I'm reading this right out of the sign chart. I know my derivative is negative. So the fancy way to write derivative negative is f prime of x is less than 0 on this interval. I could also write out the words. So my other option here is instead of writing this, I could say f prime of x is negative. Okay, your choice. I'll give you a minute there, and then we'll do example 2. Okay, see, this wasn't so bad. And I think it's kind of fun. I like the sign charts. And if you learn the sign charts, we can apply them to so many things, okay? Remember position velocity? We can apply it to position velocity acceleration, okay? I can get it into a sign chart. I know I can understand the problem, okay? All right, let's keep going. So let's do example 2. So on what intervals is the function f of x equals x cubed minus 3x squared minus 24 plus 3 increasing or decreasing? So you guys told me last time I take the derivative and set it equal to 0. So my question to you is, what is the derivative of this function in example 2? So what's my derivative? Tell me in the chat. It's derivative of my function. All right, so 3x squared minus 6x minus 24. I got to set that equal to 0. Okay, what am I supposed to do now? What do I have to do next to solve this guy? Oh, nice. A GCF maybe. Good, 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 good. Okay. So we're going to pull out a 3. We always are looking for that because we are definitely not going to be multiplying 3 times 24 by hand on the AP test, right? We're going to look for that greatest common factor. Equals 0. Okay. Did you need to sit on my lap? Is it time for a nap? Okay. No? Okay. You do your game. Well, I'm almost done, okay? I've got to just finish this example. Are you going to put your thing up there? Okay. All right. All right, so I'm going to factor, and I think when I do magic x, I get x plus 2 times x minus 4 equals 0. What happened? My helper slid some stuff here. Okay, so who remembers the name of this? Okay. What property do I use? What's the name of the property I use next? Just curious if we remember the vocabulary. What's the name of the property? And you guys are awesome. Yeah, zero product property. Okay, technically, and this is just a different way to see this. Technically, I have 3 terms there, right? So I'm going to keep the 3. And if I set that equal to 0, that just doesn't work. So we really don't get any critical points off of that. So I'm just writing no. Instead of dividing it out, okay? I could do it either way. I'm just showing you something slightly different because maybe you'll see it different somewhere else. Who knows? Okay. X equals -2 and x equals +4 are my critical numbers. Okay, I'm going to get out my sign chart and draw my fences. So I'm going to make my intervals at the top. My first interval, because they didn't give me anything, is going to start at -infinity. My next critical number, because I want to do it from smallest to largest in the critical number. So it's like we're walking the number line. So from -infinity to -2, I draw my fence. My next yard is -2 to 4. And then my final yard is 4 to infinity. Okay. We have quite the party going on here doing our calculus this afternoon, don't we? Okay. All right. So let's pick a number. Okay. So what number should we pick that's between, you guys tell me in the chat, between -infinity and -2? What do you think we should pick? Let's see if I've trained you right. Are you laughing at something? Ah, -10. Good job, you guys. You have learned well. All right. What about between -2 and 4? What should we pick? If we pick this between -2 and 4. -1 would be okay, but I would definitely prefer 0. All right. And then I'm going to choose 10 in between 4 and infinity. Okay. This is just easier. All right. I'm going to find my most simplified, easiest to plug into my derivative is going to be that guy right there. Okay. Because I'm going to really quickly and easily be able to see the signs, and I'm not having to square something in my head. I just want to look at the signs. Okay. So I'm going to start with this blue one here. And I know when I plug in a 4, the 3 is always going to be positive no matter what I do. Okay. When I plug a negative 10 into here, I've got a negative. This is bordering on ridiculous right now, but at least they're not screaming at each other or me. And then when I plug a negative into this one, we've got a negative again, right? Because a negative 10 minus 4 is going to be a negative. Then I got to think about what happens when I multiply these two together. When I multiply these together, so I multiply positive times negative, I'm going to get a negative. Negative times negative, I'm going to get a positive. So this is positive here. All right, let's try it second. The next one I'm doing green. So I know the 3 is always going to be positive. I plug the 0 into here, I'm going to get a positive. I plug the 0 into this one, I'm going to get a negative. So I'm just kind of scribbling above there. Okay. So I get a positive times that was a positive. Okay. Is positive times negative is negative. I think it's a way different color. Let's go pink. All right, so I'm going to put it underneath. So I know the 3 is positive. I put in a 10, I get a positive. I put in a 10 into this section here, I get a positive. So positive times positive times positive is going to be positive. All right. So when here comes a question for the chat. When the derivative is positive, what does that mean about the original function? So when the derivative is positive, what does that mean about the original function? Nice job, everybody. It means it's increasing. Excellent work. And then this means it is decreasing. Okay. So we're going to write our nice little sentences out now. Okay. So F is increasing. I don't know why I pick on increasing first, but I tend to go increasing on. And I'm going to read this interval and this interval, right? Negative infinity to negative 2 with a bracket. And bracket 4 to infinity parentheses. Okay? And it's because the derivative, right? What's going on with the derivative is that it's positive. So you have to say that in fancy math words. F prime of x is greater than 0, positive, on these intervals. Good job. All right, let's talk decreasing. Let me do something besides green. Let's do F is decreasing on, okay, and I read the interval right out of the sign chart. Negative 2 to 4, because what's going on with my derivative? F prime of x is negative. The fancy math way to write that is less than 0 on this thing. Helps us just complete the sentence. Okay, all right. Pretty easy, right? Very straightforward way of analyzing a function. Okay, that's where I'm going to stop my live lesson today, other than we need to do a joke, right? And you learned how to do visual aids. So he's got, like, your sister showed him something else. Do I have any questions or concerns as I'm getting to the joke of the day?